Welcome back, Algebra Tours. We have to take a second and think about what in the heck we were actually learning about before this crazy coronavirus started. So we're going to take today and do a quick video to review the things we were working on before things got weird. So why don't you grab out your notebook? You're going to have to be taking notes in your notebook because unfortunately we don't have our foldables at hand anymore. We just got a couple examples I want you to get written down in your notebook. So go ahead, grab that out, grab something to write with, and maybe a calculator. All right, so the first thing we were working on was simplifying radicals, and now you'll notice here I don't have just a square root, so we have more fancier radicals. This one is a cube root. We also have numbers and variables under there, so if you remember, you might want to grab out your pink sheet to help you with those numbers that we're a little bit less familiar with. Take out your pink sheet, and from here, whenever I had a radical that dealt with both numbers and different variables, we want to split it up and give them each their own radical. So the cube root of 48 and the cube root of x to the fifth. So when I look at the cube root of 48, I want to look down my cubes list, and if I try and pick out a number that goes into 48, you'll notice 48 isn't on it, but we try to find a number that is on it, and it looks like 8 is in that list. So cube root of 8, and what times 8 gives me 48? That would be 6. So then the cube root of 8 goes poof and turns into a 2, and we leave it as the cube root of 6. Looking over here then at our cube root of x to the fifth, again, this jail only lets groups of 3 out. So how many groups of 3 can get out of 5x's? Looks like I can take one out. And what would be remaining underneath there in jail would be 2x's. Now my final answer, again, I want to put it all back together. Write everything that's on the outside together. Make sure you're careful about how you write that cube root. And combine everything that's on the inside together. So again, yes, I might have gone through this a little bit quickly, but it's supposed to serve as just a refresher to kind of jump back into things and make sure we remember the things that we did learn right before school got crazy. The other things we were doing then were our operations with radicals, and remember, operations just means adding, subtracting, multiplying, and dividing. So we just have a couple quick examples here to run through. The first one is when I'm adding. So if you think back to that flip book, I believe it was purple, the flip book tells us when we're adding radicals, we need to make sure that we have a common term. So I'm going to break down both of these roots here to see if I can get them to be the same root. So when I look at 48, I want to think of the biggest perfect square that goes into 48. The one that jumps into my brain would be the square root of 16. The square root of 16 goes into 48 3 times. That's going to go poof, turn into a 4, and I have 4 square root of 3. Now I'm adding that to, for right now, I'm just going to kind of ignore this 5. Pretend it's not there for the time being, and I'm going to break down just the radical of 12. So the biggest perfect square that goes into 12 would be 4 square roots, and that would be 3. So 4 times 3 gives me 12. This is going to break into a 2 root 3. But now here's the part where I can't forget about that 5 out front. This 5 has to come down and join the 2, but how does it join the 2? Hopefully, since you notice that there's no operation here and we assume multiplication, it still is multiplication here, which makes this 10 square roots of 3. So I have 4 square roots of 3 plus 10 square roots of 3. When we're adding like terms, again, we're still talking about how many square roots of 3 I have. When you add 4 and 10, you get 14. So your final answer for this first example would be 14 square roots of 3. For the second example, here we are dividing. And remember, when we're dividing and we have the same root here, we can put them all under one big root. So I'm going to have 16x to the 10th on top and 2x squared on bottom. So for the time being, again, we can kind of ignore this radical and just look at that fraction that's under that radical. I can take 16 and divide by 2 to give me 8. And when I have x to the 10th on top and x squared on bottom, remember this is the quotient rule with our exponents. That means I'm going to subtract 2 from 10. So I should have 8 x's left on top, none left on bottom. So I'm going to bring down that cube root sign then. And again, this just goes back to the previous slide where we just have to simplify this radical. So let's give them each their own radical. Cube root of 8, cube root of x to the 8th. The cube root of 8 then is 2. So that one just becomes 2, nothing left under the radical. And if I look at the cube root of x to the 8, now again we're talking about a gel that only let pairs of 3 out. How many pairs of 3 can come out? Looks like I can get 2 pairs of 3 out. And how many x's would be left in jail? Looks like I don't have 2 left in jail. So if I were to write a final answer here, I'd get 2x squared cube root of x squared, and that would be your final answer. Okay, again, if you have questions, make sure you jot them down. It is kind of quick. We are going through this kind of quickly, but I just wanted to make sure that we had kind of a refresher before we jump forward. So jot those questions down if you still have them as we kind of cruise through this. The last standard we learned before the corona hit was solving radical equations. So our solving radical equations works just like order of operations. Our goal is to get this radical standing alone. So let's put that in its own set of parentheses if we may, because we want to get that standing alone. So reverse PEMDAS tells me that I need to do addition and subtraction first. So I'm going to get rid of this 5 by subtracting it. So then I'm going to be left with 2, the 4th root of x minus 5 equals 4. Then I'm going to divide both sides by 2 to get the 4th root of x minus 5 equals 2. But now I got to get rid of this this radical now. So how am I going to get rid of the 4th root? Hopefully we remember back to, since what gets rid of the square root is squaring, then we can think, well, putting the power of 4 on a 4th root should get rid of that 4th root, and it does. So again, what you do to one side, you do have to do to the other. So on the left-hand side, we're going to be left with x minus 5. On the right-hand side, 2 to the 4th comes out to be 16. If I add 5 then to solve for x to get x completely by itself, I get x equals 21. And remember, when we're solving these radical equations, we always have to check for that weird word, check for extraneous solutions. So make a mental note that we do still have to check that, and all we have to do, this means we got to plug 21 into the original equation. So I'm going to do that scratch work over here. So 2 4th root of 21 minus 5. On the outside, we have plus 5 equals 9. So hopefully the left-hand side is going to equal 9. So 2 4th root 21 minus 5 would be 16. 4th root of 16 is 2. 2 times 2 is 4 plus 5. Looks like I do get 9 equals 9. You can go over here and check that 21 is a good solution. Now again, we only did a couple examples of each, and it was pretty quick and pretty brief. So if you have any questions, this week's the week that we want to clear those up before we move forward into new material. So jot those questions down so we can get them answered when we meet at our first conference, our video conference. So I want to thank you for taking good notes. Again, this video was optional, but if you are struggling to remember what we did, it's good that you did take the notes. So I applaud you for doing that, and have a great week.